friends, in last video we have discussed about equal allocation, allocation of frame. Today, in this video, we'll discuss about proportional allocation. So, as we have already know that in equal allocation, frames can be split among processes, and these processes can get an equal share, right? So, we have already discussed about, suppose we have m frames, right? And we have n process. So what we get m by n frames to each process. So m is frames and n is process. So each process will get n by n frames, right? So in this video we'll discuss about the proportional allocation. In proportional allocation, what we are trying to allocate available memory to each process based upon its size. So here in this method, size of a process plays an important role, right? So we can understand this with the help of a method where we are using certain notations to understand how we can allocate each memory, available memory to each process. So suppose I am using a small si. This small si indicates the size of process. Size of process, say Pi. So if I am saying S1, S1 means size of process P1. If I am saying S2, it means size of process P2. If I am saying S3, it says size of process P3 and so on. And then I am using a notation capital S. This capital S means summation of Si. Right? It means summation of size of all the processes. Then what we have? We have M here. So M, what we have? This is total number of frames. How many frames we have in memory? Right? And finally, what we have? We have AI. AI is nothing, it is basically allocation. Allocation for process Pi is equal to Si divided by capital S multiplied by M. Right? So let us understand this with the help of an example. Suppose if I am saying that M is equal to 64, right? And there are two processes, say process P1 and process P2. These processes in the form of S1 and S2 or S2. We must have for process P1 what we have, say suppose 10, and for process P2, the size of process is 127. Then we have to calculate the allocation for process P1 and allocation for process P2. So allocation for process P1 is equal to S1 divided by capital S multiplied by M. So this is near about 10 divided by 137 multiplied by 64. So this is nearly about 5 frames for process P1. Right? Similarly, I can calculate allocation for process P2. It means S2 divided by capital S multiplied by M. So here what we have, S2 is 127 divided by 137 multiplied by 64. So this is nearly about 59 frames for process P2. So here we can easily understand for process P1 the number of frames required is less as compared to process P2 because the size of process P2 is large as compared to the size of process S1. So that's all for today's lecture. Thank you so much.